Yes, dear students, once again I welcome you in session 2. How are you doing? Hope all of you must be enjoying your studies nowadays. Now in session 2 we are going to just interact with each other. Interaction with each other means I shall be just discussing some topics, and in between I will be asking you some questions also, and for that you have to keep your notebook and pen ready. All right? Now my sound is reaching to you because of physics, and I'm sure your sound will come to me also when you give answers. So keep giving answers and keep solving the problems when you are asked. Now, in previous session, we discussed this scalar quantities, vector quantities, motion, and rest. So, right, in session 2, we are going to discuss distance, distance and displacement, and uniform motion, and then speed and average speed. These topics we are going to discuss. Though I have mentioned here velocity and average velocity, we shall be discussing in session 3. So distance, displacement. Distance and displacement, if just I ask you, some of you must be knowing that distance is a which kind of quantity? It is scalar or vector? It is a, yes, answer is coming to me. Distance is a scalar quantity. And if we talk about the displacement, it is, we discussed in, yes, session 1, it is a vector quantity. So we shall be discussing these two now in first topic, and then after that this motion, uniform, non-uniform, and then speed and average speed, right? So be ready. Now to start new topic, first of all, we are taking one example. I am using word we because we are studying, not I am teaching you. We are studying, interacting with each other. So first of all, here this is the point. It is being represented by O. O is the house of the student, house of a student. He has to go to school. School is here at point D. D is the destination, school. So he is starting from O, and he is reaching to, he is taking this path. He is going from O to A, then takes a turn, then A to B, and B to C, right? And after that he takes turn again, and he reaches to school D. D is the destination, so he has reached here, right? Here AB is how much? AB path which he has covered is, sorry, not AB, it is OA. Nobody said it is sir, OA. OA is 50 meter, and AB is how much? 20 meter, and BC is how much? 30 meter. And here CD is CD is, who will say? Yes, CD is 100 meter. So this is OA, AB, BC, and CD. This is the total length which he has covered, length of the path he has covered. So this total length of the path which he has covered, in physics we call it distance. We call it distance. Okay, so we come to know about a new physical quantity which is known as distance. So, and his brother, younger brother, he is taking another path to reach to his school. So he is taking this O to E, and E to D he is going. So in this case, to reach the same destination, is school, the length of the path which his younger brother has covered is different here. Okay. Now distance in both cases is different here. Though destination is same, but the distance in both cases is different. Now how do we find? You have to write down in your notebook. Keep your notebook and pen ready, and keep writing also, right? So from this, what do we come to know? That distance is the actual length of the path covered by a moving body. When a body is moving, only then it will cover distance. Moving body between initial, here is school, and house, and final is school, between initial and final position, irrespective of direction. Direction has nothing to do, okay. Here you can see how many times he is changing direction and reaching to school. His brother is going in a different direction and reaching to school. So now how much is the total distance? So in the meantime, some of you must have calculated it. So here total distance by first boy, means elder brother, is OA plus AB plus BC plus CD. This way we add, and what do we get? We get 200
meter. And distance covered by his younger brother, length of the path OE plus ED. It comes out to be 70 plus 50. If you add, what do you get? 120 meter. Now, what are the properties of distance? So, distance, when a body is in motion, obviously it will cover some distance. It will cover some distance. So, distance can never be zero for a moving body. Moving word is important here. For a moving body, it is always positive because it has no direction. It can motion can be in any direction. So, it is always positive. Scalar quantity. So obviously, when it is having no direction, there is no direction. Only we have to measure the length of the path. So it is a scalar quantity. Now this point, fourth point is very important, that it is not a unique path traveled by a body. Okay. So not a unique path means when you have to reach to school when you have to reach to your school from your house. So there may be different paths to reach to your school. So therefore, there is not one particular path. It's not a unique path, right? So it can be in any direction. We have done earlier also. It can be in any direction, right? So here I have taken some examples here. It is a rectangular path. If a boy is starting from A, he is coming to B and B to C. Then in this case, total distance will be AB plus BC. Now in this case, if a boy is starting from this point and taking around here and coming back to this point, then distance covered, how much distance will be there? How much distance covered by him will be there? So it is a circle. It is a circle, right? And then when a body is moving around a circle, okay, so one round it has taken. And the formula to find out the circumference is 2 pi r. So therefore, in one round, distance covered by the body will be 2 pi r. Okay. Now, after that, next topic.
Now, after knowing the definition of distance, how to calculate the distance, it is very important. So as we have discussed that it is a total length of the path covered by a moving body. So now I am taking this example here. You are starting from this point A and you are going by car A to C, C to D you are going by car again after taking some rest. Then you are starting in this direction, E you are coming to E. From E you are going to point B with your family. Now how much distance has been traveled by your car? So here total distance covered will be AC plus CD, length of the path, plus DE, and this is EB. So if we calculate this and if we add all these lengths, what do we get here? We get 750 kilometers, right? Now second example here I am taking, there is a circular park. This is the circular park and a boy has to run from this point A to point B along this path. This means half of the circular park. Now he is starting from A, now coming to this point, now you can see he is running and reaching to point B. And the radius of this circular park is 21 meter. 21 meter. Radius is represented by R, so R is 21 meter. So how much distance he has covered when he is going from A to B along this path? So this is how much? Pi r, half of the circle. Circumference of the circle is 2 pi r. Circumference of the circle is 2 pi r. Here he is covering half, so it will be how much? Pi r. Right? So pi, you know the value of pi. What is value of pi? Yes, 22 upon 7. And radius is how much here? 21. So what do we get when we write 22 upon 7 into 21? We get 7 3s are 21. 22 into 3, 66. One thing is very important. Never multiply this 22 with 21, because you know if you multiply these two quantities, you will get a big number. Okay, big number, then it will be a bit difficult for you to divide by 7. So go for simple mathematics. Now in second case, another boy is there. He is starting from O point, center of the circle. Now how is he running? He is coming to A point. Now from A he is starting here. So now O to A, and then from A to B he is coming to this point. Now how much distance he is covered? He has covered. So here you can see the total distance covered will be how much? So first, this is the length of the path OA. It is, and then after that, this pi r. So this, how do we get? 21 plus 66, 87. So 21 is a radius, 66 we have calculated. Therefore, total distance covered is here 87 meter. Now we are going to discuss next point, that is displacement. Displace means change in position, and change in position of an object is always in a particular direction. How far the object is there from its position, from where you are discussing it, and in which direction the object is lying. So therefore direction and distance both are there. Therefore we talk about the displacement, that it is a vector quantity, because it has both magnitude as well as direction. So what is displacement? Change in position. It is the change in position of object in a particular direction here. And how do we measure it? It is measured at the shortest distance between the final and initial position of a moving body. When a body has moved, when it has covered some distance in a particular direction, right? So, to find this displacement, what do we do? Final position of the object and minus initial position of the object or body. So here I am taking this example here in the figure. You can see there is a path here, and on this 0, 2, 4, 6, and these are mentioned here. Now, so a person is starting from this position A, and he is going up to E point, and here E point is 7. So if you ask that what is the displacement here, so how can you find? So here it is write down here in notebook. It is how much? 7, and final position, and it is what is initial position? 0. So 7 minus 0, it comes out to be 7 only. So displacement is here 7, right? Now in 7 meter. Now after taking some rest, he is going to his destination, that is B. Now he is going from E to B. Now it is at 12. This is 12 meter. So now what is the final position? 12. So what is the displacement in this case? B minus A. The B is 12 and A is how much? 0. So 12 minus 0, it comes out to be 12 meter. Now displacement is 12 meter here. He is 12 meter away from his initial position in this direction. Now after taking rest, now he is coming back. He is coming back to this point E. Again he stops here, right? So now in this case, how much is the displacement now from B to E is how much? It is 12 here, 2 and to 4, and this is 1, 5. So 12 is the displacement from this position to this to B to E is a 12 meter, right? And now when he is here, so now how far is he from initial position? Now what is the displacement here when when he is standing here? Okay, he is taking some rest. So now displacement from this position, from where he started, is AE, and it is how much here? It is 7 minus 0, 7 meter is the displacement now from initial position. Now this is one more example here. You can see the person is starting from this 2 meter distance, and now direction is changing and coming to this point. Here it is 10. The total displacement of this person is 10 minus 2, 8 meter is a displacement. Got it? Now when he is coming back from A to E, he is going right, and then he is going to B. Now B to E, Now he comes back to E. So, from A to E, how much total distance he has covered? So how will you find this distance? So this means AB, total AB plus BE, AB plus BE, the total distance. So here AB is how much? 12, and BE is how much? This is 5. So total distance, some of you must have done, I'm sure it comes out to be 17 meter. So here we have taken this example, and we can see that for different position displacement is different. So we shall be discussing more examples here in next. Now we are taking one example in which distance and displacement both can be calculated together. Here, when your family is starting from this your house, which is being donated by which position? Point A. So A to C, your car is going, then C to D, and D to E, and E to B. Okay, now you have reached to your native place to see your grandmother, right? So during this journey, how much distance has been covered? Distance covered is here how much? It is total 50 plus 100 plus 200 plus 400. It comes out to be 750 kilometer. This 750 kilometer distance is being shown by the odometer of the car, which is used to measure the distance, right? Now distance, now second time after reaching back, again next month your father is going to your native place and you are also with your family. So now he is taking another route and he is taking this route, and A to F he is going covering how much? 160 kilometer, and F to B 120 kilometer. So here total distance, now odometer is showing total distance covered is 160 plus 120 comes out to be how much? 280 kilometer, right? Now in these two cases, this journey and this journey, this displacement A to B, this is the shortest path between your house and then native place. It is shortest path. How much it is? It is 200 kilometer. Now, but how I have calculated here 200 kilometer? Yes, some of you must be giving answer. So here we can see that when he took turn here, he made 90-degree angle. So this is 90-degree angle is there. Now this AB is how much? 200 kilometer displacement. Now how to calculate this 200 kilometer? So we shall use the Pythagoras theorem. Pythagoras theorem you are taught in mathematics, right? So Pythagoras theorem will help us to calculate this displacement AB because it is right angle triangle and the side opposite to this right angle triangle is hypotenuse, right? Hypotenuse. So using this Pythagoras theorem, AB square is equal to AF square plus FB square. Then we write the values of AF and FB. What do we get here? 25600144000. After this on addition, what do we get? This 4000. 4 zeros are there, 4, and here it is 4. Now how will you find square root? So AB square is equal to 40,000 and AB will be out of this 4 zeros because 4 square root of this 4 zeros are there, so therefore we can take out of 2 1 0, out of this 2 1 0, and square root of 4 is 2. So this displacement AB comes out to be a 200 kilometer. 200 kilometer. But here displacement in both cases is same. So you can see the length of the path in both cases is different, but the total displacement from this your house is how much? 200 kilometer. So in one example we have calculated this displacement and distance. So here mathematics, it plays very important role in physics. So you have to improve your mathematics also. Now what does this displacement tell us? It always helps us to know two things, that how far is the final position of the object from the initial position, and second, it tells us about the direction, in which direction is the object when it is seen from the initial position. Now have you ever thought, is there any condition when displacement and the distance are equal? No. Some of you must be knowing. And before going for that condition, I shall like to discuss magnitude of displacement is always less than or equal to the actual length of the path covered by a body. Why it is always less? Why it is always less? Always less. Why? Because in previous slide we have discussed that it is a shortest distance. Shortest distance between initial and final position of the body. So therefore it is always less. Always less. But equal, for equal case, now we are coming to this. Magnitude of displacement is equal to the magnitude of distance when. Now some of you must be writing, or some of you must be giving answer, and yes, answers of some of you are coming to me. Now, when the body is moving along a straight path, now it is bodies, or I am not talking about the body, I am talking about the you. You are starting from this point, now coming to this point. Now you see how you are moving, and now you come to this point. Now after this, you are not going back. You stop here. You stop here. So you stop here, you are not going back. In this case, you can see this is the total distance and this is the total final position is there, initial position. So distance and displacement both are same. Got it? Now in this case, you can see displacement is equal to the distance traveled by a body if the body is moving along the straight line in positive direction or in one direction. This is very important question, and generally it is asked for 1 mark in exam. Here we were talking about the magnitude of displacement is always less than or equal to. Here you can see distance and displacement. In this case, these two are equal. So therefore, if we write value of distance here, suppose it is 200 meter. And displacement is also 200 meter. So 200 upon here 200 is equal to 1. Right? But in previous topic, in previous example, distance was more, displacement was less. Therefore, it is greater than 1. Now coming to the next. Now characteristics of displacement. So what are the characteristics of displacement? Displacement is a vector quantity because it has magnitude as well as direction. It has magnitude as well as direction. So here when the boy is starting from this point O, he is going to right side in right direction, and here displacement is 4. So therefore here it has magnitude 4 and direction right direction. We can say it is going to east direction. Therefore it is a vector quantity. It can be 0. It can be 0 if you are starting from O point. Now you are starting from O point and going to A point 4 meter and coming back to O, then displacement is here 0. So therefore it can have 0 displacement when you go to school and come back to your home. Then your displacement is 0. It has positive value. It can be positive or negative also. So when the body is moving to right side, then it has positive value. When object is moving towards left, this is origin and it is going to left side, then it is negative value here, right? Now one more case is there. If object is here, this is the original position. If you throw the ball upward direction, then it is positive. When it is coming back to your hand, and when it is dropped, it is going down here this way, it is going down, then displacement will be negative. Now you are starting from this point O, now you can see, and you are going to 4, this point A. So your displacement is positive. Now you are coming back to O, your displacement is 0. Now you are going to left. Now you are reaching here. Now you are at point B. Finally you are here. So here displacement from initial position O, from initial position O, when you are here, then displacement is -4, because here it is minus. On scale it is -7 minus initial position. It comes out to be minus. The minus sign here, it shows a direction. It is negative towards left. But the absolute value of displacement is always in positive. It is +7, right? Now in second case, when you are here, from here, when you were here, from here, what when you are coming to point this B, what is your displacement when you were here? Sorry, when you were here, and what was your displacement when you come back to this point B? So here, what is the displacement here? The final position is -7 minus initial position, it's 4, -7 minus 4, it comes out to be -11. So -11 is showing that you are on left. You are on left. And here minus means left, and here total this absolute value of -11 is +11 meter displacement from here. Now it is how much? It is 11 meter displacement. You were here and now you are coming here. So total displacement is 11 meter. It is on left. It is for a certain period of time. It is independent of the path followed by body. So here you can see this for this point example. So from A you are starting, you are taking round and coming to B point. Your displacement is this A to B. Now in second case you start from A and then you are coming to this B from this side. Again you can see here displacement is AB. So it is independent of the path followed by body, whether you are going from this side or you are going to B from this side. This displacement will remain same. It doesn't depend on the path followed by the body, right? Now therefore it is a unique path. Distance is not a unique path. Here displacement is a unique path. It is only here one. It is a unique path, right? So, okay. Now measurement of distance and displacement. Again, good example has been taken here. You can see a man is moving from A to B, B to C, and C to D. This is total 6, and it is 4, and it is AB. Here total distance when a person is starting from A to B, and B to D, and finally he is coming to D. Total distance is 3 plus 4 plus 6 comes out to be 13. Right. Now if you are asked how far you are now from initial position when you are at D and you start from A, so this is the displacement, and this is which triangle? Again you can see it is which triangle? Right angle triangle, right angle triangle. So again you must be recalling, taking help of mathematics, we are using which theorem? Pythagoras theorem. Square of hypotenuse is AD. Hypotenuse is the side opposite, it is the longest side in the right angle triangle, opposite to the 90-degree angle. This is opposite to this. This is the longest side, right? So AD square is equal to AE square plus DE square. You can write in your notebook. AD square comes out to be 16 plus 9, 25, and AD comes out to be 5. So here displacement is how much? 5 meter. Displacement is 5 meter. Right, so this way you can practice some other questions, so problems at home. Now we have discussed up to this. Thank you. In next session we shall be discussing this velocity and average velocity and acceleration, and then what are the types of acceleration. Thank you very much, and I'm sure that you must have understood, and now you will be given some questions on portal and you will be able to solve. Thank you. Enjoy your day and enjoy each and everything. Enjoy sorrow, enjoy happiness, enjoy problems. Whenever you are given any problem, just try to enjoy it and you will be able to solve your problem. Thank you very much once again, and God bless you.